So last Saturday, actually, we've discussed about functions. I haven't yet uploaded the notes. I forgot to upload. Later, I will upload the notes, the functions. So Saturday is just a quick review, summary on functions, what we are going to have, and then what's the emphasis on functions. Okay. So the expectations is you know how function works, how to identify the functions, how to transform the functions, how to combine function with other functions, how to inverse the functions. Okay. And yeah, basically that is the section about the function. Now, one of the typical functions is we call it polynomial and rational functions. But we're starting with polynomial functions. So polynomial, okay, poly means a lot. Okay, nomial it means the nominal, the number. Okay, which means that, let me write here. Let me sit here. So if we say the polynomials of degree n, okay, if we say we have some degree, usually we write in terms of p of x, and then let me write all the terms here. And the coefficient an should not be equal to 0. Okay, so when n equals 0, of course this p will be a constant. And when n equal 1, then p will be a1x plus a0. So, in other words, function that you have learned before, don't worry, we've just started. This is just the beginning. We just started. So as you know, functions like linear functions or quadratic functions, that is degree 1 and degree 2. Okay, so we describe in more general with terms polynomial. It means we can have a lot degree, higher degree. So if we take n equals 0, it will be a constant. If you take n equal 1, it will be, seems like a linear. And if you take n equal 2, it will be quadratic, and so forth and so on. Okay, okay, we have just started. Okay, don't worry, we will just stop. So, and it means that this coefficient here, it means that you can put like any n. Okay, you can put 5, 4, or even 100. You can be also. So it's a whole number. So maybe let me write here for n equal to, we already know that this will be a quadratic functions, which is, I will put the arrow here because it's already written, that is there. Okay. So the one we have here, the quadratic function is the polynomial function of degree 2. So of course, the one we have here, ax squared plus bx plus c, the one we also learned before. And I hope you get the idea how to factor it, okay? Because that is, I think, fundamentals. Also, how to make it into standard form is also fundamental. And from that standard form, you can write how to get the quadratic formula that I believe most of the students in the world that learn math, they memorize it. Okay, and then the standard form is actually, we rewrite this function, we rewrite this And then write into this form, okay? We call the process complete the square. Complete the square. So we can make x minus h squared, and then we have still a, factor a here, and then plus a constant k. Now this h and k, it will become the vertex. It can be minimum or it can be maximum. It depends on a. A can be positive, can be negative. Can be positive or negative. You could think the function x squared, like this, right? So if the function is negative x squared, maybe you could also imagine how the reflection works in functions. So if you have x squared, like this. If you have negative x squared, then it's like this, right? So if you have a negative a, it will have maximum. If you have positive, you have minimum. Okay? It's something that you don't need to memorize. And I don't think you need to write all of this. Just write the keyword, okay? I hope it helps. Okay? Like this one and this one. Okay, this one is how it looks like. So it has the vertex here, which means a minimum point. The vertex here is the maximum. And the point here is always the h or k. H or k. So whenever you have a quadratic functions and you can determine the standard form, you can rewrite, you can make it complete, the square, then you can find the point for the vertex. Okay. Let me write on the side here, just an example. Okay, so if we have this, what we can do, we are going to try our best to complete the square and making the standard form. We can try. Can you try for a while? What should we do first? Any idea? Yeah, factor out. So first, maybe we factor 2 first, and it become x squared minus 6x, and then plus 13. Yeah, and then this x squared minus 6x, we can complete by make it the squared, right? So 6 divided by 2 and then squared. So 3 squared is 9. So we need to plus 9. Okay. We need to plus 9. And then what? Can we do that? What's missing?
Plus
Yes, plus and minus, or maybe taking this minus here. Okay. So 9 multiplied by 2 is 18. So to make it confirmations, we need to minus 18. Okay. We need to minus 18. Okay. So we can write this become a complete square like that, and then this will be not plus, sorry, minus 5. So remember that this is h and k, but remember the form is minus and plus. So the point here is 3 and negative 5. So the vertex, is 3, negative 5. This is f of x. Let me write here. So if you have this, another important point why this complete square seems really helpful is if we look here and if we relate to transformation of functions, we can see that this function is actually a function of x squared multiplied by a factor of 2, which makes it vertically stretched. And then we shift it to the right side 3 units, and then downside 5 units. Do you get it? So let me write here. Okay. So this is y equal x squared stretch vertically by factor of 2, and then shift it to the right 3 units, and shift it downside 5 units. So by taking this, you can start to imagine visualizing functions, and sometimes I believe there are some students, and for me personally, I prefer to visualize something in graph, because some people might learn more enhanced if he can visualize. Some if he listens, some maybe if we do something. But for me, visualization is my thing. So describing things in your mind is much more easier in graphs. So maybe if you
What the vertex not be? -3, -5?
No, because this one is the form standard.
Oh.
Yeah. Maybe a little bit. Oh, okay. And then from this, also you can see from these functions, we can see the intercept. Okay, I think we have also talked a little bit on intercept last time. So the intercept, we can check the intercept. For example, let me write here. So the y-intercept, meaning when x equals 0, this is just 13, okay? And then x-intercept is when y equals 0, which means the f of x need to be equal 0. Or we need to factor out. But since we have already the complete square, we can write down here let me write here f of x, or maybe let me write 2x minus 3 squared minus 5 equals 0, and we are going to find what x that makes this 0. So we can start to work out this. Move to the right and then divide by 2. So x minus 3 is plus minus square root of 5 over 2. Or I have x equal 3 plus squared 5 over 2, and then x 3 minus squared 5 over 2. Okay, that's the x. Or we say, sometimes we say the roots, sometimes we say the zeros, they are the same thing. You will see later, we are going to use the word either roots or zeros. But they are actually the same thing. The one that makes the polynomial zero. So this is the x-intercept, okay? This is x-intercept. Intercept means the one that they are crossing the either y-axis or x-axis. In this case, it's x-axis. So they will crossing the x-axis at this 2 point. Okay? And they were crossing the y-axis at the 13, y equal 13. Okay, and then we see we can also make maximum minimum value. Actually, we can also try to draw this. Okay. This will be something like that. It's something like x squared, but stretching with factor 2, move to the right 3 units, move downside 5 units. And at this 5, this will be the minimum point. So we can have the maximum or minimum value based on the same standard form of the quadratic formula, ax minus a squared plus k. Okay. It has maximum or minimum value at x equal to h. Okay, so with this 0 equal to 0. So we have the minimum value or maximum value depends on the value of a. If a is positive, then we have minimum value, like we did in the example. That is the minimum value. If we have a less than 0, we have the maximum value. Okay, so it's supposed to be like this. So actually, we can try and guess if you are going to roughly sketch the graph using this information. You can focus on important points rather than trying one by one and then you pinpoint all the positions. So you can start by taking the vertex. So you can take the vertex. Let's say we have, this is 1, 2, 3, 4, 5, this is 3. I think I need to make it more clear over here. Maybe, let me make it a little bit smaller, maybe 1, 2, 3 over here. So 1, 2, 3, 4, 5. Negative 5. So this is the vertex. Okay, so the vertex is around here. And then the 5/2 is around 2.5, right? 2.5. If you take the square root of that, 3 plus something, 3 minus something. So it's supposed to be around this 2 points. So maybe this will be around here, and this is just my estimations, maybe not really that correct. 4, 5, maybe here, maybe around here, and we can have all this, and then the y-intercept is 13, so we have 13. So 1, 2, 3, 4, 5, 6. Let me just write here. Maybe this is 13 over here. And then we connect all of that. Of course, not proportional, but it's supposed to be really smooth. Before the quadratic equations, the quadratic functions, it's still easy to imagine how to roughly sketch the functions. But if we increase the polynomial, and if we make some combination of degree in the polynomial system, there will be something that interesting. The more precisions for sketching the graph, I think that will be in the calculus. We will have application of derivative, actually, in application of differentiation and derivatives. Okay, now if you see the functions of the quadratic, they're right here. And then let's factorize a. So x squared, and then we have b over a. Okay, let's make this form. Okay. And then we forced to make a standard form like we did before, but using ABC. Okay, using ABC. So we take this and divide by 2 and then square. So b over a divided by 2 become b over 2a. Okay, and then squared. Yeah, b squared over 4a squared. Right. So let's write that. So plus b squared over 4a squared. So we need to also multiply with a. So we take minus a. Let me write all the things here like that. So at the end, the function can be written as x or a. A. This is x plus b over 2a, and then squared, and then plus c minus, I will cancel the a, b squared over 4a. Is this something familiar with you? In high school? No? Okay, that's okay. This will be H. This will be K. Okay. So to make this zero, we need X equal to negative B over 2A. Can we go all through? Yeah, and we can have your early classes. Maybe we can finish 8 something, okay, 8, 15 or 20. Is that okay? So if X, so when X is equal negative B over 2A, this component will be 0, right? So that is when actually we get the maximum or minimum. So when we take the negative B over 2A as our value of X. Okay, now I think what else? Do we have some example? Okay, let me give you some example. So if you have f of x, negative x squared plus x plus 2. Okay, for some reason I think you can't factorize like a normal, but for the standard form I think you can do it for most of the quadratic function easily, right? So I think start with the factor the negative and we get this, and we get, so divide by 2 and then squared. So do we 1 over 2 squared is 1 over 4. So plus 1 over 4. Then we need also to minus. Remember, minus plus, so it should be minus 1 over 4 should be plus, right? So this will be, let me just write minus 1 and 1 over 4, okay, to make it clear. So we are going to plus. So this is actually 2 plus 1 over 4, which is 9 over 4, right? So we get x minus half squared plus 9 over 4. So max value at x equal 1 over 2. Or if you remember what we did before, so x is equal negative b over 2a. This is when it's going to be maximum or minimum. So negative b is, so b is here. So this is a, b, and c, right? So negative b means negative 1. 2a means negative 1, so negative 2. So it's really half, same. Okay, the same with what we have done. Okay. So you could directly go to this and you get the vertex value, or you can complete the form and get the conclusions that this will be the maximum value when x equals 1 over 2. Or you can directly write the vertex is the 1/2, 9/4. And max value is 9/4. Okay. Okay, if we have, example, the p of x, 3x to the power of 5 plus 6. So usually, in polynomials, we are going to have like a higher degree. We call the first term here, the highest one is the leading term. This is just a terminological. It's okay if you don't know. This is just to show you that this is the degree, okay, the highest degree within this example. This is the constant term. And all the number in front of the x, this is called all the number here. The A0, A1, A2, and so forth is called the coefficient. Yeah, I think that's just the basic information. And what's the implication of the polynomial? Implication is every function of polynomials, they will always continuous and smooth. So implication, polynomial function is always continuous and smooth. Okay, if we have, for example, just a slight example here. If you have something like in your calculus class, like this, and then you have a break like that, of course it's not continuous, right? It's not continuous. And if you have something like that, this is not smooth because we have a corner. But if we have something like that, we can say this is continuous and smooth. Smooth, continuous. And probably it will be a polynomial, but not always. But probably the smooth, continuous, maybe that is the polynomial functions. And you will see the end behavior of polynomials. They are always have the similar property, which means that you can check like type in this random functions polynomial maybe with 7 degree, maybe 5 degree, or maybe 4 degree. You will see that either the left part is always going up or going down, or the right part is always going up or going down. It's always the case for polynomials. So the end behavior will be a similar. Especially for the different degrees. So we usually take the if the p has odd degree, you will have something like this, or like, oh sorry, or like that. You can always relate to the x cube. X cube is something that easy to realize. It has like this, and then the other part is going here, right? So, and for the even degree, you can always relate to your simple x squared. But I will just show you if we have more variations. Like for example, we can also make like something like this. There is something in between, but they are still in a macro scale. It's going to be like that, or like that. Maybe let me. Or like this. Okay. And this is just a random polynomials. Okay? It can be maybe x4 plus 2x3 plus blah blah blah. Okay. But the end behavior, down goes up, or goes up, goes down, or both goes up, or both goes down. Okay, later, maybe if we want to review, perhaps next week, with some exercise, I will give you more practical application, how to use all of this. But I will just give you the basic introduction first, at least on how to visualize the graphs and to find the zeros, find the roots of the polynomials. I think my main goals is to give you the introduction to the zeros. Okay, so this is the real zeros. Let me type in the real zeros. Polynomials. Okay. So if P is polynomial that we already described and defined, we have all of these conditions, which it's okay if you don't want to write this as a note, but if we take P, the polynomial, and then C is a real number, if we say C is a zero of P, meaning that the C is the one that makes P zero, we can also say that the solution that we usually find and when you factorize some functions, like quadratic functions, anything, when you find a solution x equals something, that is your solution, right? So we can say that x equals c is a solution of the p of x equal to 0. This is usually when you did the factorizations, right? And we say the x minus c is a factor. Okay? It's a factor of px. Okay? And c is also an intercept because we take this equal to 0. Okay? So this is also intercept. Okay? So I think no problem with this, right? No problem with this. So if we take the p, let's say x squared plus x minus 6, and I think we can factor this, right? We can factor, this is x minus 2, x plus 3. If we want to find the solutions with equaling this to 0, right? So we say, oh, the solution is x equal to x equal negative 3. We can say that negative 3 and 2 is a0 of p. We can say also the x equal 2, x equal negative 3. Both are solution of p. And then x plus 3 and x minus 2, they are factor of p. And we can also say that negative 3 and 2, they are x-intercept of p. Okay. Just a simple example to describe all the descriptions. I believe this is something that you have like practically used many times, right? Just to make sure that we know the terms, okay? Because we are going to see a lot of terms, factor, and then 0, factor, 0, okay, later on. Basically, what I want to say is they are basically the same thing. And we have the intermediate value theorem for polynomials. The same thing when you have the in calculus. So this intermediate value theorem is more general. This is just to say that if you have the p, the polynomial functions, you have p of a, p of b, meaning you plug in a, plug in b, and if they have opposite sides, it means that in between the a and b, you will crossing the when it's getting the x-axis. Okay. So there exists at least one value c in between a and b for which the p of c is equal to 0. Okay. So it means that, for example, here, let me show you what does it mean. Okay. So if this is a, this is b, we put into this function p of a negative, p of b positive. Even if you don't know the functions really is, how to graph the function, but you know the value. You know the value a. For example, you know a is less than b. A, you plug in here, you get negative. B, you plug in, you get positive. Suppose that you don't know the graph, but you know the truth that when you try to make up the graph, there is impossible if you are not crossing the x-axis. So that's why we have conclusion that suppose that there is c that is in between a and b that makes the p equal to 0, which means that this is getting crossing here. Okay. Okay, I think we have something here. Maybe let me try to give you some basic idea how to sketch the graph roughly. So let's take the example here. So let p of x equal x cubed minus 2x squared minus 3x. The first question is find zeros of p, and second is sketch the graph of p. So find zeros, I believe you know how to. I think it's factorizable, so you can factorize the functions. But how to sketch, okay? So basically sketching the graph for the polynomials, first is we get zeros, right? Zeros is the x-intercept, okay? So we get the x-intercept, which means we know when the curve will be crossing the x-axis. And then second one, we get to know the y-intercept as well, right? When the graph will crossing the y-intercept. That is when x equals 0, right? Which is 0, right? 0, 0, right? And then the rest, we need to take some times, maybe make some line number, and then check some value of some x, okay? So let me write here. We can factorize this p. We can write p of x and write here. This is x. We can factorize x, become x squared minus 2x minus 3. And I think we can factorize this, right? So x, 3 and 1, right? Negative 3 and plus 1. Okay. So we have 3 zeros. Okay. So x equals 0, x equals 3, x equals negative 1. Which means that this will be the x-intercept. So x-intercept is when x equals 0, x equals negative, or maybe let me write from negative 1 to make it in order, and then 0 and then 3. Okay. And we can also write the y-intercept directly when p is at x0. So when p at x0, it will be 0. So it is going to be at the center of the x and y axis. And then what else do we need? We need a line number to check whether the number between or in all this area will be a positive or negative. So we can check that. Okay. So check negative 1, 0, and 3. You can check from negative 1 here, left side, maybe negative 2, negative 2, negative 2, negative, negative, positive, negative, negative, right? Okay. And then in between negative 1 and 0, maybe negative 1 over 2 or 1 over 3 is okay. And it doesn't mind calculate the value itself. The important thing is the signs. Okay? So negative 1 over 2 is negative. Negative 1 over 2 is will be positive. Negative, 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 negative will be positive. Right? Yeah. Right? Negative. Okay, be careful. Okay, be careful. Sometimes you forget to, for example, this x plus 1. Okay? If you put negative 1 over 2, so 1 minus 1 over 2. It's supposed to be positive. Yeah? Positive. Okay. So positive, negative. This become this is positive. all the number in between, and then check through the. I think it's easy to check this, right? Because it has the x minus, x plus. So every number you can think, you can. If this is bigger, then okay. Like for example, x equal 5 is bigger, it's positive, right? And then 5 is also positive, positive, positive. It's safe to say that the right side is positive, okay? But when it's between 0 and 3, you will see that we have x minus 3. Yeah, something that is in between here, it will be less, right? So if we take 1, it will be negative, it will be positive, positive, negative, 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 positive, negative, right? So this will be negative. So what's the implication for this negative and positive values? So we are going to see that this is actually we have in the negative region. This will be in the positive region. This is in the negative region, positive region. But how to make sure the value is correct? That way, we need to check some numbers. Okay? Maybe some easy number. We can check some easy number. Maybe we can check maybe from x. This is p of x. We can make some table. Just some small table. It's okay. So we check negative 2. This is negative 10. Negative 1 is 0. This is the intercept. And maybe negative 1 over 2. Negative 6, 7 over 2. 7 over 4. 7 over 8. 7 over 8. So sadly for our basic math, you still need to calculate some value just to make sure the proportions, okay? To make sure the proportions. So 0, 0. And then if we put 1, this will be negative 2, negative 4, right? Negative 4. And do the rest, okay? And just to make the general graphs. So we take the number which is 0. Let's say negative 1 is here. 2, 1, 2, 3. 3 is over here. So it should be having something going through here. And then let's say 1 is here, so it should be here, 7 over 8, right? Over there. And then we have 1 is negative 4, so it's already here. So it's actually getting down really, maybe not proportional, maybe over like that, and then going up. Maybe something like that. Okay. So we say that this part here, we call this the local max. We call this local mean. Okay. Why we call that local? Because it doesn't really show you the lowest point. It has a behavior like this, and it has behavior like this. But it doesn't mean that this is the highest one, and this doesn't mean this is the lowest one, because we have, I think in here, we're getting like negative infinity if we take the limit. Okay? This is also getting larger and larger. And that is polynomial. The polynomial always getting, the end behavior, they're always, if not negative infinity or infinity. Okay? It's getting larger and larger, positive or negative. It can be like this, like that. It can be like this, or like this. All polynomials, the same. The differences in polynomial is, I think, in the middle. In the middle, there will be like this, and then maybe some other curve going on in between. But that can be explained through either intermediate theorem or the maximum minimum value that we can get from some numbers. And how many local max or min within the graph? We have two, right? Two. What is the polynomial? It's the x cubed. So every polynomial, they will have the extreme point at least n minus 1. The x squared, you have only one vertex, right? X cubed, you have two. X to the power of 4, you will have 3. So we have 3 like this. Right. Okay. So we have x to the power of 5, we have 4 local max or local min. I think I will write that for you, okay, so that maybe it's, if you think that's important. I think I will write here, okay, I will write here. If P is a polynomial degree n, then the graph P has at most n minus 1 local extreme. For example, fx equal x squared, it will have 1, right? If you have, or if it's degree 2, maybe like this. This is n equal 3, this is n equal 2. Okay, now we have some concept on roughly sketching the graph, and then we know how many extreme points we have in the graph. Now we are going to have this. This is the theory of multiplicity. So multiplicity is how many times you will have the factors. For example, you will see something like this. Okay, maybe let me just put some example here. You will have x with power of 4, and then multiply with x minus 2 with power of 3, multiply x plus 2, x plus maybe plus 1 squared, like that. The number 4, 3, and 2, it will describe the multiplicity. We get it from this this shape here. Okay? So if the multiplicity is odd, like for example 3 over there, the shape near that intercept, which means x equal 2 in this case, it will get this or this, okay? Like the cube, okay, because it's odd. If that is even, like this x equal with power of 4 or x plus 1 squared, which means that nearby x equals 0 or nearby x equals -1, it could be like this or like this. Okay? So it's helping you to decide when you have the intercept, what can we do about that? Okay? How does the shape will behave? How the shape looks like? So I think we can try this one here. So it means that we already have the 0, so it's x equals 0, x equal 2, and x equal -1. This is all the roots or the zeros, right? The solutions. So 0 has a multiplicity of 4. You can write m equal 4. X equal 2 has the multiplicity of 3. X equal -1, it has m equal 2. We can also check how it looks like in the graph by checking the line numbers first. So taking -1, and then 0, and then 2. So check all the numbers in between, okay, nearby these zeros. So checking the, let's say -2, positive, negative, so negative. So let's say this is positive, negative, negative. Oh, it's supposed to be positive, sorry. So negative was negative. And then -1/2. 1/2, -1/2 is positive, negative, so negative, positive, so negative again. It's another negative. So it's interesting. It's negative and then negative again. And then between 0 and 2, let's say 1, we get negative, positive, negative. Again, it's negative. But when we have more than 2, we have all positive. Okay. And then we need to check some points and some values to check the proportions. And I already have here, so we don't need to count. So eventually, line number say that this is negative, this is also negative. So what's happened here between this -1 and 0, they both are even multiplicity, right? So it means that they have this going here, okay? And then the 0 here is going to have that. Okay, this one is even, and then this is odd. So when x equal 2, it has going here and then going back. Okay? So the importance of the multiplicity is to decide or determine how this and this, okay, deciding whether at this point it's going to be this or going to be odd. Okay. Of course, there are some table here that is checking the proportions, like how low this point will be and how low this point will be, okay, to make the graph still in the proportions. So expectations is, if you get some functions that has this kind of multiplicity, you could decide what it really looks like at certain points. Okay? At least how to describe this power of 4, power of 3, power of 2 within the graph. And what does that will imply? And you will see that in the graph here, it will imply this even and odd multiplicities, differences between them. Maybe any questions first? Okay. I think it's better like if you see the picture, right? Which one is even and odd? Sometimes silent means if he understands or she understands, or she is in the process of understanding everything else once, which is very confusing. But I hope not. I hope not. I'll review again next week in more practical sense. Okay. Okay. This is the one before. I think we skip this. We have now known that one. Another part, aside from the zeros, sketching the graph, is the dividing polynomials. Okay? Dividing polynomials. Why this is in this, like we have zeros, and then we have the sketching the graph, and then suddenly we have the dividing polynomials. Okay? You will see that later. Dividing polynomials will somehow relate it to how to find the solution or to find the zeros. Okay? Because when you define some polynomials with other polynomials, or maybe with some other equations as well, you will see that we can rewrite, like for example, if the P and D is our polynomials, P and D is our polynomials, we can rewrite this P and D as this structure. So it means that if we, for example, if you would like to divide, like maybe maybe x 2x cubed plus 3x squared minus 6. Really random. I'm not sure what kind of this. Maybe we divide with x minus 4. Okay. So let's divide, and I don't know what number will be. So 2x, so this will be 2x squared, right? So we multiply here. We have 2x cubed, and then with 4 minus 8x squared, right? So we subtract, just like you did in your elementary school, divide just like usual division, and then this will be canceling. And then we have 3 minus 8. So 3 plus 8 is 11. So 11x squared. And then still we have a constant negative 6. And then we have another square here. So we need to plus 11x, which gives another multiplications. 11x squared minus 44x. Now we can cancel this, and then we have 44x minus 44x. So you can say that we have 0 minus minus, so we have plus. Okay, we have plus 44x. So 44x and then minus 6. Okay? And then we take again. And really, this is ugly, right? The number is ugly because I make it randomly. So let's just using this. So 44x, OMG, 16, 176, right? 176. Wow, really ugly. So this is 170. So this is what we call the long division. So we have, now we can write down 2x cubed plus 3x squared minus 6 divided by x minus 4. We can write that as 2x squared plus 11x plus 44 plus, let me put this over to there. Let me shift this part a little bit to the left. And we have 170 over x minus 4. So 170 minus 6. 176 minus 6 is 170. Is that wrong? What is my mistake again?
I thought you had to.
No. It's not clear yet for you.
You said negative 6.
Minus.
Which is added.
So plus 176. Plus 176 minus 6.
Sorry. Okay.
Okay?
Yes.
Get it? Okay, so basically what this division will be implying is we are going to restructure this P over D, become this Q and R and D. Okay? This R we call the remainder. Okay? This Q we call the quotient. This is the divisor. Okay? But I don't want you to memorize all this, but one thing you need to know is the R, okay, the remainder. The remainder is the one that is, if your division is not completely become 0, if it's something overlap, like when you did some division when you're elementary school, it's not 0, it's not completely divided. The left part, we call this is the remainder, something that still remains. Okay, so this will be the R. So this will be the R, or this is the remainder.
That bottom part is right there. So in the very first part, when we multiply that 2x squared times x minus 4, shouldn't have that 8x become positive because the down part is already negative. So when we're multiplying 2x squared times negative 4, then that becomes positive.
How to make it positive?
It's like
Explain to me.
so
Then explain to me what you mean.
This one part is still negative in order.
Yes.
So
It's the same. It's the same. But I'm actually taking all this and directly subtract. Okay? What you did there is like before you take it into negative.
Yeah.
So the same thing. What I did is I directly take it into negative. Okay? So I subtract all with negative. Okay. I think this part is just introductions. Not really important. The important one is when you do division, you can do it well, okay? So we have two methods. First one is we call the long division, which we have done within this, okay, which have long division. But let me use the more reasonable functions or reasonable equations that can be done. Okay, let some px at 8x with power 4 plus 6x squared minus 3x plus 1 and d of x is 2x squared minus x plus 2, and then find qx and rx such that p of x is equal d of x. This is actually the same thing as the introduction, but this is just to write it in the fancy words. So it's actually the same thing with this part here. So what we do is actually we are going to define p with d. So we are going to define p with d, and then we find our q and r. So this is actually the same thing when we did this. So divide by d. So this will be qx plus r over d. So what we have here is basically we are going to define p and d. Okay. So we take the long division as usual. And I will let you try. Okay. So let me write here. Let me write the first step. Write all okay, and this will be 2x squared minus x plus 2. Okay, if you are not really familiar with the method to define this, and you see that it says power 4 and then suddenly power 2. You don't have the cube, right? Like if you want to practice, you can plus the x cubed but 0. Okay? Just to let you know that we have actually x cubed but it's 0. But I think it's okay if you already know how to subtract or divide and then subtract like you did when you have in your elementary school, and you have familiar with that. I think it's still okay. The difference is now we have polynomials. Okay. Okay. Now, what to write? What's to write the first one here?
4x squared.
Yes, 4x squared to make it this, right? So make it this, and then we can subtract. Okay. So we can write 4x squared, and then we multiply with that. So we have 8x with power of 4, and then minus 4x cubed, and then plus 8x squared. Nicely, we subtract this. Subtract. This will be cancelled. And we have 0 minus 4x cubed for the x cubed, right? So we have 0. So we have minus will be 4x cubed. Or maybe let me write here to make it clear. And then 6x squared minus 8. So minus 2x squared. And then we have minus 3x and then plus 1. Okay. So you need to be careful. For now, you can take slowly. Okay, take slowly. And then plus 2x. And then we have subtract that. So we can cancel. and then it is also can be cancelled. I think that's nice. So we have negative 7x plus 1.
Sir, why do you switch the signs for that? Like it goes from negative 4 to positive 4. That's when you're cancelling out negative 2 minus 2. Why do you switch the sign? Where, so, for here it goes from negative 4 to positive 4. Why?
Because I said before, do you have any x cubed here?
No.
0,
Yeah.
minus, minus. 0 minus minus become?
Positive.
Okay. Okay. So that's why I told you before, if you're not familiar with this, we can write here just to practice, okay, just to practice, because if you're not able to do this like usually, so we can write this as 0, x cubed, like that, okay? I know it's weird, but this is for make it habit, make it a habit. You can start with 0 here, because sometimes if you're not careful, you will maybe missing something here, and then maybe you will get the wrong conclusions. Okay, so this will be the R. And this will be the Q. Okay, so we can write that 8x4 plus 6x squared minus 3x plus 1 divided by 2x squared minus x plus 2. This will be equal 4x squared plus 2x, and then plus, let me write it with bracket to make it safe, and then over okay. Okay, this is what we call the long division. So we define the terms and really long. Another method we call the syntactic division. It's more simple, precise, but has limitations. For something like this, we cannot do the syntactic one. So let me make a new example. So this will be the last part for today, okay? So let me just get you one more method, and then we have done for today's class, okay? So the second one is the syntactic division. Okay. Okay, so suppose that we are going to divide this. So we are trying to divide this. Of course, if we want to take the long divisions, we can do the same as well. So we can take this and then divide with this, and then take some time, multiply, subtract, multiply, subtract, multiply, subtract, and then until the last part, until we have the remainder. Okay? So that's the first method. The second method is we are going to use the syntactic division. How to use that? So the method. So let me write here. So this is the long division. So I will write here, this is the one you have learned before, long division. You can try by yourself. Okay, this the one that I will focus more is the syntactic one. Okay, now remember, if we are able to completely define this, and then there are no remainder in the bottom, it means that we can completely define, right? So, in another case, if we plug in that factor, this is factor x minus 3, which means x equal 3 is a solution, if it is a polynomial that has solution. So x equal 3 will be a solution. Now, with the same logics, then we could try to make out that solutions into our polynomials. Okay, so we can start to write the synthetic. Or let me explain the techniques first, okay, and then we can explain the later part. Okay. So to use the synthetic division is we are going to write the coefficient. So 2, oh, it's happening. Okay, so 2, -7, and then imagine that in between this we have x, right? We have x here, so let me write with 0x, okay? So we have 0 and we have the constant 5, okay? So write all of that. So 2, -7, 0, and 5. And then we put something like this. And then on the left side, it is going to be supposed to be your solution, which is x equal 3, okay, instead of x minus 3. So how we can make it into our divisions? The first term, we just let it down. Okay, so we put down. So let it down. 2. Okay. Next thing, 2, we multiply with the 3. We have 6, we put here. Okay. We put 6. Now we add them. Okay, we add. So this is adding. So we add, this will be -1. And then the same thing, -1, multiply with 3. So we'll go with 3 here. So this will be -3. Okay? So -3. And we have -3. And then we get -9. And then it's going to be -4. So the -4 will be our remainder. And these 3 terms, 2, -1, -3, this will be the quotient. So what will be the quotient? The quotient will be 2x squared minus x minus 3. Okay? It's actually pretty simple. It's actually pretty simple. I'm not sure who is the founder of the synthetic division. Maybe I need to find out who. It's really helpful, especially if you have like a polynomial functions that can be described within this synthetic division. It could be helpful. But synthetic division has limitations. It can only define the factor like this. If you define like with another polynomial, for example, a quadratic one, then we cannot do that. Or you still can try to make this synthetic. If you can factor out these quadratic functions, become factors like this, you can do this.
Like, if we factor that quadratic constant, x, example like x minus 3, and then another one is x plus 2, maybe.
as long as we can define with these terms, still can use. So if this is coming out from the quadratic one, still can define. But we still have the other factor. Yeah. Okay. Okay. You can try the long division if you want to make sure that we have correct answer. So we can check this is 2x squared. Yeah, the first one is already correct, right? 2x squared, 2x cubed, minus 6x squared. This is negative 7 plus 6, right? So negative x squared. And then, what else? Just this one. And then plus 5. And then we have minus x, because we want to make this cancel. So this is cancel. So negative 3x plus 5. And then negative 3. To make it negative 3x plus 9. And then cancel. And then negative 4. So we get the same result, the remainder, and the quotient. Okay.
Wait, sir, how do you know the degree the coefficient is 4? So do you just bring it down like 1 degree?
Which one?
Like, for example, like 2, negative 1, negative 3. How do you know that the degree for the coefficient 2 is x squared?
Yeah, so we get this remainder.
Yeah.
So if we have this is like 1, 2, 3, we have the quadratic function. If we have only 2, it will be linear, right? If we have 3, it will be cubic, and so forth.
They basically goes in order.
Yes, yes. Basically, we go the order. Yeah. Okay, I think we'll end up till here. I will have more practices next week. Okay. And before we end, I think I have